Again, welcome to today's webinar, Migrate Your Existing Express Applications to AWS Lambda and Amazon API Gateway. Our presenter today is Stefano Bugliani. Stefano is a Specialist Solutions Architect for the AWS Serverless team. Prior to this role, Stefano was a Product Manager on Amazon API Gateway in the AWS Mobile Group. Stefano spent 12 years working as a developer and solution architect for a number of SaaS and PaaS startups before joining AWS as a product manager. Today with us we also have Shiva and Or, who will be our webinar moderators, answering your questions throughout the presentation. Stefano, welcome. The floor is now yours.
Thank you. Hi everyone, as Heather said, my name is Stefano. I'm a Specialist Solution Architect at AWS. Our webinar today is all about migrating Express applications to serverless architectures using AWS Lambda as our compute platform and Amazon API Gateway as our front end. We are going to start by highlighting the benefits of both products and the reasons why a lot of our customers have started adopting serverless architectures. We'll look at one particular use case, the API-first migration to the cloud, because it's very relevant to porting existing applications to serverless architectures. And then we'll introduce the new features we launched in Amazon API Gateway that make it easier to port existing apps to AWS. And also an open source library, the AWS Serverless Express library we published on GitHub. This library is specific to Express and Node.js, and we'll show you how we can use this to take an Express application and run it inside a Lambda function. We'll give you a live demo of this process, and then we'll close with some best practices and tips. So let's get started. Amazon API Gateway is one of the new products at AWS, and it allows you to create an API front end for your existing or new services. A lot of our customers have built APIs over the years, and they've used the best possible technology at the time. However, when they find themselves trying to open these APIs to third-party developers, the various services often look inconsistent with one another. So API Gateway allows them to abstract their implementation and create a unified RESTful API that translates and proxies requests to their existing backend services. Another reason why we've seen AWS customers adopt API Gateway is our network protection capabilities. With API Gateway, we have taken what we already do for ourselves at AWS, DDoS protection at the edge, and the ability to throttle requests before they hit the backend, and we productized it and made it available to your products. Another very common pattern is to offload the authorization tasks at the gateway layer. This has multiple benefits. First, once a request hits your backend, you can trust that it has been authorized and it has been through that security layer. Secondly, it gives you the ability to centralize all authorization tasks and decision in a single place. In this case, Amazon API Gateway. What this means is, for example, your backend doesn't need to have access to the secret keys you use to open your tokens. And finally, very commonly for developers who want to monetize their APIs and sell them as a product, API Gateway allows them to throttle and meter utilization by third-party developers. Our compute platform, in this case, is AWS Lambda. Lambda is the latest compute service we launched at AWS, and it's the highest level of abstraction. With EC2, you're used to thinking in terms of hypervisor and an actual machine. With the EC2 container service, you only need to worry about the OS, and everything is in your container. With Lambda, all you need to worry about is your code, the function that you want to execute, and the runtime it runs on, Java, Python, or Node.js. More than that, with Lambda, we do away with all of the boilerplate code you normally write around an application to start the server, accept requests, etc. All you have to work with is your function code and business logic. Lambda charges you on a per request basis, and the compute time is measured in increments of 100 milliseconds. What that means is that if you want to build an API, you don't need to have an instance constantly running, waiting for requests. If your API does not get called, then you pay 0. If you do receive requests, you only get charged for the requests that we actually handle and execute. And finally, Lambda has built-in scaling and fault tolerance. What that means is that there is no infrastructure at all for you to manage. You won't have to set up auto-scaling groups or worry about distributing instances across multiple availability zones. AWS Lambda takes care of all of that for you and gives you an easy invocation API to simply trigger your code. So this is a use case we've seen a few of our customers take on now. As they move from their existing data center or perhaps another provider to the cloud, they start with their APIs first. The challenge with migrating APIs to a different data center is that you obviously don't want to cause downtime or disruption for third-party developers that interact with your application. So the pattern we've seen very often is that they place API Gateway in front of their existing services. API Gateway in this case mimics exactly their existing API, so that as far as developers on the outside are concerned, nothing has changed. However, now that they have this layer of abstraction in front of their services, they can start migrating to AWS. One pattern we've seen is what we call lift and shift. Take one of the monolithic applications that they were already running on-premise and simply stand it up on an EC2 instance. And then it's just a matter of flipping a switch in API Gateway so that the API methods that needed to interact with that particular backend are directed to the service on the EC2 instance rather than the on-premise one. And obviously, all other requests can keep going to the on-premise service. Other customers take the opportunity to also re-architect their applications. API Gateway gives them fine-grained control over what the backend is. Each method in your API can have a completely different backend. For example, the get to /hello can have a different backend from the post to /hello. So our customers often start taking their applications apart and separating it into microservices. Perhaps there is what was before an online shopping website gets split into a catalog service and a payment service. These are ported into two separate Lambda functions, and then only the relevant method for those microservices are flipped in API Gateway to point to the new Lambda function. This use case is particularly relevant for us because a lot of the customers who are adopting this were building applications with Node.js and Express. And so we have seen them take their applications apart and split them into smaller Express apps as they bring them over to Lambda and API Gateway. Because this use case was becoming so popular, we've introduced a few new features in API Gateway that make it easy to migrate applications. The new features are catch-all resource paths, and we'll go deep on each one of them in the next slides. The any HTTP method and the proxy integration types for your API methods. Let's start with the catch-all resource path. When you define an API with API Gateway, we ask you to specify the structure of your API, its resources, and its methods. However, very often customers just want to get started quickly and bring their application over. Catch-all resource paths allow you to simply define a variable followed by a plus sign, and that tells API Gateway to intercept requests to all sub-resources. In our example here, anything that comes under /orders would be intercepted by that /proxy plus path. This makes it very quick to bring applications to API Gateway and Lambda. It's still possible to define the entire structure of the API, and if you do, you have the advantage of being able to use the Swagger definition of your API to generate documentations, and generally just use the open source Swagger toolkit. All of these new features are also available in Swagger. For example, in this case, the catch-all resource paths can be defined just like any other path in Swagger with the plus notation. The any HTTP method, as the name suggests, tells API Gateway to intercept any HTTP verb that comes to a resource. So where before you had to define the get, the post, the delete individually, you can now simply define an any method, and API Gateway will just intercept all requests and send them through that single integration. Similarly to the catch-all resource paths, the downside of this is that your Swagger definition will not be well defined, and you won't be able to generate SDKs or documentation using the Swagger toolkit. So while one gets you started very, very quickly, the other is likely to generate benefits in the long run as you scale your application and your business. To use this in Swagger, we've created a custom extension. As you can see in our example here, under this /proxy plus path, we have defined the Amazon API Gateway any method. And finally, proxy integrations. We've introduced two new integration types, the HTTP proxy and the AWS proxy. What proxy integrations do is allow you to skip all of the input and output mapping steps that before were mandatory in API Gateway. If we take a look at how this works, in our example, we have a /catalog path, and you can see that it's a catch-all resource path with path plus and has an any method underneath it. We can define the integration for that any method as an HTTP proxy. In this case, API Gateway will simply pass all of the requests through to your backend, and once your backend responds, we'll just pass the response out. And API Gateway is only in charge of throttling and authorization. Similarly, in our example under the orders path, we have an any method that's integrated with a Lambda function. When you use the AWS proxy integration with Lambda, API Gateway automatically applies a transformation to the request and generates an event body for Lambda with all of the information we have about the request, about its context, and the API Gateway context itself, such as stage variables, for example. What we expect back from your Lambda function is the structure defined there that contains a status code that you want to return, a body for the response, and a map of headers. If you have custom headers to return, API Gateway knows automatically how to translate that data structure into an HTTP response. These new integration types can be used in Swagger using the same type tag we had for integrations before. So our simplest possible API in this case is one that has a catch-all resource under the root and an any method under that catch-all resource. That's basically telling API Gateway act as a proxy and send all requests and responses through. It's very simple, and it still applies to the serverless architecture pattern and tenets, which is scales automatically, there is no infrastructure to manage for you, and you only pay for the requests we actually handle. We've also updated our API Gateway console to configure these new resources. While in the APIs and in CloudFormation and in Swagger, these are treated as 3 separate features, in the console, we made it even easier to set up a proxy API. You can see that when you create a new resource, you can simply tell API Gateway to configure it as a proxy resource. We will automatically populate resource name and path. And once you hit create resource, we will also automatically create the any method underneath the new proxy resource. And so all you need to do is tell us which Lambda function we are talking to. These new features make it very easy to set up APIs with API Gateway and Lambda. To help customers who wanted to bring express applications to our serverless services, we've introduced this new Serverless Express library. The way the library works is it wraps your Express application and it receives those events from API Gateway and proxies them to the Express app running within the Lambda function. So if we look at the path of a request, it will first hit API Gateway. API Gateway will apply the default transformation to the request and generate that event body we have seen for Lambda. Once the event hits Lambda, the Serverless Express library will first start your Express server on a local socket within the Lambda function. And then it will take the event and out of its data generate a request object, a standard Node.js request object, and pass it to the Express app on the local socket. Once the library receives the response from the Express application, it simply transforms it into that data structure that API Gateway expects, with a status code property, a body string, and a map of headers. So migrating an Express app is a very simple process. It takes just a few steps. The first thing will be to pull your dependencies from NPM. In our case, in our demo, it will be simply the Express server itself and the AWS Serverless Express library. You'll have to create a JavaScript wrapper file so that the Express library can start the server on the local socket and proxy requests through. And then all you have to do is zip up your entire application, create the Lambda function for it, and then set up the API Gateway proxy resource. In our demo, we'll go through all of these steps. So this is what the JavaScript wrapper looks like. As you can see, I'm simply importing the AWS Serverless Express library. I'm importing my Express application in the app.js file. And then I'm telling the Express library to start the server. Finally, my Lambda function handler simply uses the proxy method to send requests back and forth. So let's take a look at how we can do this in practice. First, let's take a look at the code of my Express application. As you can see, my Express app is inside a file called app.js. It's a very, very simple app in this case. I'm just importing Express. I have a /hello path that accepts GET requests. And it simply says hello world or hello whatever name was passed in as a query string parameter. And then it starts the app. One thing you'll notice here that is probably different from the basic hello world Express app is that I am also exporting the app object. This is because we need to use it in a Lambda wrapper. If we take a quick look at the lambda.js file, we can see that this is the wrapper example we saw in the slides. You can see that I'm importing the Serverless Express library. I'm importing my application, and that's why I exported the app object. And then I'm simply telling the library to start the Express server on the local socket. I'm doing this outside of the handler because Lambda will run this code only once, the first time my function starts. From then on, it will simply call the handler. And obviously, I want to start my Express server only once. Another thing we've added to the library is an Express middleware. The Express middleware we created gives you access to the API Gateway context for the request. If you remember, in the event, we received all of the request properties, all of the headers, all parameters, and the body. But we also received the stage variables and the API Gateway context, such as the Cognito identity ID of the caller. By using this middleware in your Express application, you will have access to all of that information in the request object. Let's take a very quick look at the Serverless Express library. It's a pretty straightforward library. As you can see, we can start with the proxy method. This is what the Lambda handler function calls. Best practice, we're being paranoid, so we always double check whether the Express server is started and listening. If it's not, then we'll start it again and then forward the request. Otherwise, we simply call this forward request method. So let's go and take a look at this method. The first thing it does is create a request options object. This is the normal Node.js request object. If we go to this function, you can see that it's simply reading the event data, for example, the headers, into a map. It's adding a few custom headers, but then it's just creating a plain JavaScript object. You can see it contains the HTTP method that we've been called with, the path that we've been called with, the headers, and where our local socket is. So once we have this, we can simply create the HTTP request with Node.js, write the body to the request object, and then forward it and execute it with the local Express server. Once we have received a response from the Express server, this method gets triggered. All that this method does is read the response and then create that object we're familiar with a status code, a string for the body, and a map of headers. With this, then we call the standard context.succeed method in the Lambda function. So let's go and set this up. The first thing I will do is navigate to my application directory, you can see it here, and create a zip file with all its contents and dependencies. So now our first step is to create the Lambda function. Let's go through that. The first thing Lambda presents me is a choice of blueprint. Blueprints are sample functions that also come with an event handler package. So if your purpose is to handle a file being uploaded to S3, you can just pick one of our S3 example, and this will give you both the sample code and the event mapping to an S3 bucket. Similarly, you can pick one to consume Kinesis streams or even DynamoDB streams. In our case, because I want to show you exactly how this works behind the scenes, we're not going to use a blueprint. We're just going to skip straight to configure the Lambda function. Let's give our function a name. I'm going to call it JS Express. We need to select a runtime, and in our case we're using Node.js. And then instead of editing the code in line, I'm just going to upload a zip file. Here I have my archive.zip we just created. And next we need to select a handler. The handler is what Lambda will trigger when it receives an event. And the format of the handler is filename dot function name. So if we go back to our code, you can see that our handler is inside lambda.js, and it's called handler. So let's set that up here. I want to call lambda.handler. The execution role here defines what the Lambda function will have access to. When the Lambda function starts, it will assume this role in your account. And for example, if you need your Lambda function to have access to DynamoDB, you should specify that in the execution role access policy and give it access to scan, query, or put item to your DynamoDB tables. In our case, a Lambda function simply says hello world, so it needs no access. I'm going to use the default basic execution role. The advanced settings give us the ability to configure the amount of memory that's allocated to the Lambda function and the timeout for it. There's a bit more to this than what we'll talk through now, and we'll go over this in more detail in the best practices slide. For now, I'm going to leave this at 128 megabytes of memory, because that's plenty to say hello world, and I'm going to set the timeout to 5 seconds. And finally, Lambda wants me to select whether I want to grant access to a VPC. This is helpful, for example, if your Lambda function needs to query an RDS instance or an Elasticache instance. If you need to have access to a VPC, you can simply select your VPC here and which subnet the Lambda function should have access to. In our case, we don't need any VPC. So I'm just going to accept the settings and tell Lambda to create the function. There we have it. We have our first Lambda function. You can see that the Lambda console is showing us the content of that lambda.js file. We can also test it here. If you select Configure Test Event, Lambda has a list of possible test events generated by other AWS services. And you can see that one of them is the AWS Proxy in API Gateway. And this is the event that gets generated from API Gateway. When you invoke a Lambda function as an AWS proxy, you can see it contains the request context, query string parameters, if there were any, a set of headers that were passed in with the request, and more importantly, an HTTP method and a path. In our case, because our Express app responds to GET requests to /hello, this is the right configuration. We can just test it. You can see that this has now started the Express server, and it's proxied the request, and it's generated the response structure we expect. We have a status code. The body has been passed back as a string with JSON content and a map of headers. Most of these are the default headers generated by Express. So now we know that our Lambda function is working. Let's go and set up the API for its front end. We can go to the API Gateway console. Here, API Gateway is asking me to create an example API using the standard Swagger pet store example. This is because it's the first time I open API Gateway in the new US East 2 or higher region. In our case, we are just going to create a new blank API, and let's call it Express Demo. Now API Gateway is asking me for the structure of this API. You can see here I have a resource tree and a method editor on the right. For our simple example, we are just going to create a proxy resource. So I'm going to select Create Resource and then tell API Gateway that this is a proxy. You can see it's pre-populated the resource name and the path for me. Another option we have here is to let API Gateway handle the course pre-flight requests. If you're familiar with course, you know that browsers first make an options request to your server before making the actual API call. If I enable this option, API Gateway automatically generates the options method under the resource, and it handles it as a mock integration. So it will generate the response by itself without pinging my backend. So let's go and create this resource. Because I told API Gateway that it was a proxy resource, you can see it's also created the any method behind the scenes. So all I need to do now is connect it to my Lambda function. I just need to select the region, US East 2, and my Lambda function, JS Express. When I save, API Gateway asks me to confirm that I want to grant permissions to this API to call the Lambda function. Behind the scene, this is making a call to the Lambda APIs and setting the permissions on the function itself. So now we have an API set up, and we have a basic proxy with an any method. We can go ahead and test it. You will see that the mapping steps are disabled for this type of integration. So let's run a test from API Gateway. We're going to make a get to /hello. You can see that this has called my Lambda function. It responded with hello world, and it returned the correct headers. If I call it again, you can see that the latency goes down because I'm hitting an express that was already started. So now the last step, to make this API publicly accessible, I simply need to deploy it. When you deploy an API with API Gateway, you need to select a stage. Stage are the equivalent of environments, and we treat them like tags. So in this case, I'm just going to say deploy it to a dev stage. And you can see now that API Gateway has allocated a unique URL for my API. You can obviously override this with custom domain names, but this is enough for us to call our API. And you can see that this has gone off and triggered our Express server, and all parameters are passed through automatically. So let's go back to our deck. What we've done here and what we've showed in the demo Looks pretty straightforward. It's a very simple setup, but it's an extremely powerful one. We've just taken an Express application that we normally run on EC2 instances, perhaps set up with auto-scaling group and over multiple AZs that we need to constantly manage and monitor, and put it inside Lambda and API Gateway. And what that means is that no matter how much traffic our Express application is going to get, API Gateway and Lambda will automatically handle it and scale to meet any throughput that you need. More than that, no server to run, so you only pay when your Express application is actually called. And a great thing is that this is still an Express application. I could have gone to my shell and said node app.js, and this would have started my local Express server running my application. And what that means is that you can test on your local box. We demoed how to port an Express application with you. We have written that very simple library to do that. But if you notice in our code, there was no black magic there. There was nothing strange. We were simply taking that event and transforming it into an HTTP request, and then transforming the HTTP response into an event or into an object that API Gateway could understand. And so the truth is that you can do the same with any other framework or language you're used to. If you're using Spring Boot with Java, there's nothing stopping you from starting your Spring Boot server inside a Lambda function and then simply proxying requests to it. The same is true for Jersey, Flask, or any other of the supported languages in Lambda. If you are starting from scratch, you may want to consider some serverless native frameworks. For example, the serverless frameworks has been one of the most popular, and it allows you to build functions and APIs with API Gateway that work with both services out of the box. Claudia.js is another very popular framework for this type of applications. Chalice, if you're using Python, is a very easy way to create functions and publish them. The great thing Chalice does is that it also creates the IAM roles your function needs based on which other AWS services your function needs to interact with. We also have Zappa, and there's a few more. I just didn't have enough space on the slide. So let's talk through some best practices to conclude. First, there is a one-to-one mapping between an incoming request and a Lambda function handling it. What that means is that your Express server within Lambda will only ever handle one request at a time. If a second request comes in at the same time, it will go to a completely separate Lambda function, an Express server. So what I want you to keep in mind here is that your Express applications, your methods there, need to be stateless. You cannot rely on a session or state being there. Also, there's no need to spend a large amount of time optimizing the concurrency in your Express methods, because only one will ever run at a time. Finally, while we were creating a Lambda function, I showed you that you had a memory settings, where you could select the amount of memory that is allocated to the function. That selection doesn't just control the memory allocated to the function, but it also controls the amount of CPU that's allocated to the function. It's one knob to control both. The higher the amount of memory you allocate, the more CPU the Lambda function will have access to. So obviously, if your Lambda function is particularly CPU intensive, or if you want to make it faster to start it the first time, the more memory you give it, the more CPU power it will have available, the faster it will start and process. The other topic we touched on is the fact that variables and functions declared in the global scope outside of the handler method are executed only once, when the Lambda function starts for the first time. So that is a great place to keep some cache when the container is being reused. However, loading too many resources and accessing too many other services in that global scope will make your first startup of the Lambda function slower. So the recommendation is to lazily load those resources. Instead of initializing them in the global scope, when your handler starts, check if that global variable is null. If it's null and you need it, then initialize it. Otherwise, you can leave it alone and not waste time on it. And finally, remember to offload tasks to the API Gateway. The fact that you can run your Express application inside Lambda means that you can use the same authorizer and middlewares that you have in your existing Express app. And you should by all means do that. But if you want to try at some point, particularly as you have multiple functions all running different Express servers that make part of the same application, you may want to centralize access control. So perhaps instead of using a middleware inside the Lambda function, inside the Express server, you may want to use custom authorizers or IAM auth inside API Gateway. This way, when you need to make a change to your authorization strategy, you won't forget to update one of the Lambda functions by mistake. This is all for us here, and I'd like to thank you all for attending, and take a note of those links there, the AWS Serverless Express library that we demoed, and the documentation for API Gateway to set up proxy resources.
All right, thank you, Stefano, for your great presentation, and for Shiva and Or for engaging with our audience throughout the presentation. On your screen, you will see 3 live polling questions. Please provide us with your feedback by clicking the radio button next to your reply for each poll. We do have about 15 minutes left, so please feel free to continue submitting questions. We will begin addressing some of those that have been submitted, but we do apologize in advance that we may not be able to get to all of them. And with that, I'll turn the floor back over to Stefano to start addressing questions.
Thank you, Heather. So Brian is asking, what can we do for cost management to reduce the amount of time the Lambda function runs each time? I think the most effective thing you can do is, as we mentioned, lazily load resources. Don't abuse that global scope. And beyond that, make sure your code is efficient. If you can avoid a round trip over the network, do so. If you have a chance, for example, an encryption key that you can cache it in the global scope, so that if that Lambda function gets executed again, you can simply read it from that scope instead of going off to perhaps KMS and loading it again. The second question from Doug is whether the node application and the wrapper remain running even after they've executed the request, and whether that will run up charges. The short answer to this is no. It will not run up any charges. Once a request is executed and we've returned a response, you stop paying. Lambda does keep your function around for a little bit longer. However, as we keep saying, do not trust it to be around. Lambda functions are meant to be stateless. So be paranoid and always make sure that everything you've cached, it's still initialized and not null, and you're not in a new function. But no, it will cost you nothing if your container keeps running after the Lambda function is done executing the request. Yes, the code is available on GitHub. So if you go to the Serverless Express library, the bit link that we have there, you will see that you have the library itself, but there's also a sample inside the library. So you have access to the exact same code. Deepak is also asking whether the Express server keeps running after the Lambda execution is done. As we mentioned earlier, it may. You won't pay for it, but Lambda will keep that function around for a little bit longer. You should never trust it to be the existing one. You should always double check that your variables are initialized properly, and if not, reinitialize it. But yes, the Express server may be around for a little bit longer. So a great question from Victor is, they're looking to build a new API using API Gateway. And they're wondering whether they should go serverless using Lambda or having a hosted Express service on EC2. Obviously, Lambda is the easiest possible solution that requires no server management. The application will scale automatically for you. If you do want to run it on EC2 because you have some particular needs, such as local storage access, for example, you can absolutely do that. When you set up an HTTP proxy with API Gateway, the endpoint we communicate with needs to be publicly accessible. What that means is that you will have to place an elastic load balancer or an application load balancer in front of your EC2 instances. And that load balancer will need to have a public IP address. To hit that load balancer, then we recommend, for example, using API Gateway to embed a secret header in the request so that you could verify that the caller is API Gateway. Or if you are using ELB, the Elastic Load Balancer, as a TCP load balancer, then you can use client-side certificates in API Gateway. API Gateway will generate a certificate and give you the public key for that certificate. When we make requests to your HTTP backend, we will always use that certificate. And you can configure your Express server to use that public key we've shared with you to verify that the origin of the caller is API Gateway. Having said that, unless you have very, very stringent latency requirements or particular requirements such as access to a local disk to keep storage in state, I would probably recommend running your Express application in Lambda. The next question is whether there is any way to allow API Gateway to accept calls from client that only support TLS 1.0. With API Gateway itself, no, we will not allow that, and for good reason. TLS 1.0 has been deprecated a while ago. However, I believe you can place a CloudFront distribution in front of your API Gateway endpoint, and you could configure that distribution to, for example, run an HTTP or allow older versions of TLS. JD is asking, how can I get dynamically the stage name from API Gateway into the app.js file? JD, if you remember when we looked at the code, we showed you that middleware that we've created within the AWS Serverless Express library. And that middleware gives you access to all of the context properties of the request that API Gateway passes and generates. It just so happens that the stage name is one of those properties. So all you'd have to do is import that middleware, tell your Express app to use it, and then you would have access to those properties in the request object. So the next question is that Lambda takes care of scaling automatically, but how do we catch a runaway process that is consuming too many resources, memory, CPU, etc.? Well, the truth is that you don't have to worry about that. As we said, Lambda will only handle a single request per function at a time. And what that means is that no other function running will be affected by one function running away with too much memory and too much CPU. Those are only limited to what you've configured the Lambda function to have. In the worst case scenario, where somehow your code has gotten into an infinite loop, Lambda would automatically kill it after 5 minutes. That's the maximum timeout for a Lambda function. The question is where every request to express is stateless. Does it mean a new container behind the curtain? Not necessarily. As we said, Lambda tries to reuse functions as much as possible after they're started. If it cannot find a function that's free and available to handle a request, then it will start a new one. And in that case, all of your context in the global scope will be null. But if we do have a function available to handle a request where perhaps you've already initialized your global scope variables, then we will reuse it. The reason why we harp so much on the stateless thing is because just like we did, if you remember, we were being paranoid and checking every time whether the server was listening or not. You should do the same. You shouldn't trust the container to always be around. You should make sure that everything you need is initialized. If not, reinitialize it. It's just a different methodology and way of thinking. Nick is asking, how can we check the number of requests served by the Lambda function and API Gateway? So both API Gateway and Lambda create metrics in CloudWatch in your account, as well as logs in CloudWatch logs. If you want to know the number of requests, API Gateway in particular logs 5 metrics for you. It logs the number of requests, so that's exactly the metric you want, and you can aggregate it to a per minute basis. It logs the latency for each request, the overall latency. It logs the integration latency, so how long it waited for the Lambda function to respond, and the 400 and 500 errors generated. Ali is asking, how does API Gateway handles authorization? There's a few ways to authorize requests to API Gateway. One option, as you mentioned, is IAM. What's special in this case is that API Gateway treats your API, your service, as if you were an AWS service yourself. If you're familiar with AWS, for example, when you create an S3 bucket, you are given an Amazon resource name, an ARN for that bucket, that uniquely identifies that resource. And that's the unique identifier you use in your access policies. Well, API Gateway assigns a unique ARN to each method in your APIs. So the get to /orders will have a different ARN from the post. What that means is that API Gateway can accept signed requests on your behalf, just as if you were an AWS service. And then you can control all access definitions using IAM access policies and roles. Many of our customers also have existing authorization system. Perhaps they have built their own auth provider, or they rely on a third-party provider. In that case, we have a feature called custom authorizers in API Gateway. A custom authorizer is fundamentally a Lambda function. The way this works is that when we receive a request with a token we have not seen before, perhaps a bearer token in the authorization header, we will trigger your Lambda function, the custom authorizer, and pass it the token and the context of the request, the resource they're trying to access. In the Lambda function, you can write your own custom code to make a decision on the authorization. What we expect back from that Lambda function is a policy that tells us exactly what that token can do in your API. When you go to create a new Lambda function, among the blueprints, there's a couple of custom authorizers blueprint that also include objects that make it easy to generate these policies on the fly. The next question is whether it's possible to have a mix of public and authorized endpoints using API Gateway. Yes, absolutely. The authorization settings are made on each method. So if you wanted to, you could say the /login or /status that does not need authorization. We'll just let every call through. Everybody has a chance to authenticate. And all other requests, for example, your user profile, you can set it, the get to your user profile, you can set it to require authorization. In this case, if you do not need to authorize access to a particular method, I would recommend not using custom authorizer or IAM at all. Simply leave it open and set the authorization only on the methods that need it. This will reduce latency. I think these are all the questions we have. Thank you very much for your time.
All right, I'd like to extend a special thank you to our presenter, Stefano, for his time and a great presentation, and Shiva and Or for answering the audience questions. If you have any comments on our previous or upcoming webinars or suggestions on the topics you wish AWS to cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thank you everyone for taking the time to join us today, and enjoy the rest of your day.